Hopefully your suffering with the most boring part of installing Postgres have been not so painful and you have Postgres in PgAdmin installed. It is finally time to have a quick warm-up before we come to a more theoretical part of relational databases. So let's have a quick exercise and have a sneak peek at what you will learn in the course. Imagine you're running an online shop and you sell some products. You get orders maybe once a day and you keep track of the records in a spreadsheet similar to what I'm showing in this example. In fact, if you're doing serious business with a spreadsheet like this, you should definitely reconsider the sense of life and keep watching this course. I will show you why having a proper database is a much better alternative even for relatively small datasets. But I hope you are not there yet and it's just the time to learn about Postgres. This spreadsheet is not yet a database, but it gives a nice idea of what are the records that we keep for an online store. It contains order ID, it contains when the order was created, the timestamp. It contains information about items, name, brand and size. It contains information about customers, first and last name, their address and age. We see what items were purchased and what are the customers who made these purchases. After some time running the store, we want to make sense of the data, such as what orders were made by a particular customer, or what is the most beloved item that everybody likes to buy, or maybe how many nasty customers we have and we want to stop selling to them. It can be literally anything that we want to see from the data. Don't worry if you don't understand something right now. We'll be going through details of every piece of this exercise in future videos. So now we want to see this data exported in the Postgres. For now we have to prepare the database first. For this, let's open PgAdmin, connect to the database Postgres as we did in the installation instructions, and let's create our first table. In the PgAdmin window we can see multiple panels. On the left side I can see the servers, on the local host that I'm connected to, the database, and by default we have Postgres database installed after clean installation of PostgreSQL server. And here I want to create an additional database for the online store that we are using. There are multiple ways. One alternative, maybe the easiest, is to create it from the UI. Although I'm not a big fan of clicking and it just takes too much effort, I want to go directly to the query tool here and start typing Postgres commands. First of all, I want to create a database, which I can do with simply create database and specifying the name. So here I chose the name of the online store that we're running and I named it Penguin because maybe in the future we want to sell some shoes for penguins, or maybe this is targeting customers who are big fans of Linux. I don't know, but let's call the database PenguinDB. We've got to put colon in the end of every line of the Postgres statement, and I can execute this query by pressing F5, which is not the update on the browser page, but it will execute the query. So now I have a database PenguinDB created. I don't see this database immediately. What I have to do is to press right click on the databases, refresh, and I see my newly created database, PenguinDB. I can click on it and connect. And here I see multiple entities that belong to the database, which are casts, catalogs, event triggers, different things. And what is that we need is the schemas part. By default, it has a public schema, and here in the schema I will see what are the relationships existing for this schema, which are foreign tables, functions, views, procedures, sequences, and here we have tables. This is the part that we'll be using mostly for this course. Currently there is no table for the public schema. So the next step will be to create the schema and the table with the data that we just checked from the spreadsheet. In the resources for this lecture you will find the SQL file that we can open from the PgAdmin by clicking public query tool and finding this open button and navigating to where you have the file downloaded. Or you can also paste the content of the file if you open it in a text editor, doesn't matter. So this file was created using the pgdump script from the default installation of Postgres. This file already contains a few basic elements of working with the Postgres database or any other SQL language. First, we want to create schema. Let's call it backend. The schema in Postgres represents grouping of any kind. We will use it to group several tables, and we will call the schema backend. When you have a big database, you might have different schemas. Maybe you have different schemas for the version of API or versions of tables, or maybe different time periods or whatever. For us, the simple case, we want to create a schema backend, and we want to create a table customer order. This is the table that will represent the data from our spreadsheet. As you can see, the language of SQL is pretty human readable. It was created by smart people. It was created with readability in mind, and creating the table is as easy as typing create table. I specify the name of the schema, dot the name of the table. I open left parentheses. I specify a pairs of values, order ID, the name of the column, and text is its type, and so on. Created will be timestamp, item relevant information text, customer relevant information text, and age is integer type. So these are several basic primitive types available in Postgres. Now I put a semicolon. Then I set the value of variable search path to backend. This will help me avoid using backend as prefix in every time I want to use the customer order table. And you can see that all the inserts below that I want to put data in the table, I don't have to specify backend dot. Otherwise I would have to. So setting search path to backend, I'm ridding myself of the need of using this prefix every time. And now comes all the lines of inserting data. Let me make it a little bit more beautiful. And here I'm inserting data using insert into customer order table. I specify a list of columns for which I want to insert the data. Close the parentheses. I say values. And here I specify the values that I want to insert in these columns. Here's 1001 as order ID. This is the timestamp for created, item name, brand, size, customer name and last name, address, age, and here we have just a bunch of inserts with different data so that we have some kind of baseline. After I press F5 again, this will be executed. And now if I update the schemas, I will first of all have my backend schema created, and in the table views, I will see my customer order table. Now here I can easily see what's in the database by pressing right click again, view edit data. Well, let's check all rows. And now we can basically see the content of the spreadsheet just inserted in the database of Postgres. Now we can actually easily do anything with this data in just a couple of commands. So a few things here to mention is, you can see on the left is 1, 2, 3 and so on are the numbers of rows. So this one horizontal line is called a row in a relational database. And here the columns represent different types of the data for each row. One individual item is called a cell. So the sneakers value is a cell that belongs to the column item name for row number 3. This is it. And now I cannot modify this particular query, but I can select and copy Control-C. And I can right click on the customer order table. Again, I can choose query tool. I can now paste the command. So I want to select all columns. The star represents a wildcard for all columns from table name, backend.customer-order. If I now press F5, I get the same data, all columns, all rows. And here, if I add a few more words, where customer last name equals dough with single quotes, and if I execute this part of the query, I will only see customer orders for which the fields in column customer last name is dough. Now we can see that the customer last name is always dough. We have 2 persons with this last name, probably husband and wife, live in the same address. So in this case, I specify that I want to filter, and I say where customer last name and the value. I have to put text in single quotes. This is the convention of Postgres. And now if I add one more condition with the specifying AND keyword, and I want to see all orders made later than 2016, I can say created more than, and in single quotes I can specify the special format for the date 2016 0101, which is January 1st. I press F5, and this way I will only see orders created in 2016 or later. In this short exercise, we just created the database, created the table, populated using insert statements, and had a look at the data using a few selects. We saw how to select all data, and we also saw how to make a simple filtering. So with this, you already learned quite a lot of concepts of the relational database. And with this short exercise, you should already feel that your hands are becoming trained to type select commands even with closed eyes. You know now the most used commands in any SQL language, and moreover, we also looked at how to select particular subset of data. Congratulations on this, and now it is time to make a short break and look at the more theoretical concepts of relational database.